Exercise 1.6, question number B1, fine, right? So look at Roman number 1, 64 to the power 1 by 2, right? So in this type of question, always look at the power, okay? You can see power is 1 by 2. After that, you look at the denominator. Denominator is what? 2, right? So the base here, which is 64, we'll try to find it in terms of a square root, okay? So 64, can write it as 8 into 8, or it can be written as 8 square, right? So see, always try to look at the powers denominator and try to do the same thing with the base in terms of square, okay? So you can see what I've written, 64 to the power 1 by 2, right? So 64 can be written as 8 square, right? So now once I open a bracket, it's going to be like this, 8 to the power 2 or 8 square into 1 by 2, right? I can divide 2 ones are 2 ones are, and you can see I have 8 to the power 1, which is simply 8 here, okay? So look at Roman number 3 again, look at the power again, okay? 1 by 3, and look at the base 3, right? So we'll try to get it in terms of cube, okay? The base. So 125, if I find the factors, 5 to the 10, 5 5 is 25, then 5 5 is 25, then 5 1s are 5. So 125, what can also be written as 5 into 5 into 5, or simply as 5 to the power 3 or 5 cube, right? So you can already see that is what I have done. Open a bracket, then once again 3 1s are 3 1s are. We're having here 5 to the power 1, which is simply equal to 5. All right, question number 2-1, same thing like our previous question. Look at the power again, 3 by 2, right? But have a look at the base, 2 is here again, right? So now this 9, I'll try to find it in terms of square. So 9 simply means, what if I find the factors, 3 3 is 9, which means I can write 9 equal to 3 into 3, or simply as 3 to the power 2. So you can already see here 3 to the power 2 here, right? So once you open a bracket, you can divide this and this, 2 1s are 2 1s are. We're still having, remember, this 3 is still left, right? So now it will become 3 cube. 3 cube means what? Multiply 3 times. So 3 3s are 9, 9 3s are 27, okay? Once again, look at the power again, 2 by 5, and look at the base, 5, right? So the base, we'll try to find it in terms of to the power 5. So 32, if I find the factors, 2 1s are 2 6 are, then 2 8s are 16, then 2 4s are 8, then 2 2s are, then 2 1. So you can see that 32 can be simply written as 2 to the power 5. 1 2 3 4 and 5. Okay, you can already see here. Then 5 1s are 5, 5 1s are 5. We still have this 2, okay? So 2 square means multiply 2 times, and we're going to get our answer to be equal to 4. All right, now question number 3. We're going to simplify, right? And I've already told you to practice and also learn the formula for all the exponents, okay? So now let's have a look. 2 to the power 2 by 3, and then 2 to the power 1 by 5. You can see that the base are same, right? 2 and 2. So what happens when the base are same? We just add the power, p plus q. Our p here is 2 by 3, and then q is 1 by 5, okay? So you can see here, this is p, this is q. So we're adding them. Now the next thing we have to do is find the LCM of 3 and 5. So if I try to find the LCM of 3 and 5, it will just be the numbers itself. 3 5s are, we're getting 15, right? Once we're done with it, write on the first numerator, I've written here. Then 3, how many times are 15? 3 5s are 15. Next is plus 1, so I've written plus 1. 5, how many times are 15? 5 3s are 15, okay? We have to find a denominator and then simplify. All right, 2 5s are 10, 1 3s are 3, right? So 10 plus 3, we're going to get 13, and then of course the denominator is 15. So this is our answer, right? 2 to the power 13 by 15. All right, Roman number 2, 1 by 3 to the power 3 to the power 7 again. First thing we'll do is, you can see that this 3 to the power 3 is in the denominator, okay? So we'll bring it up in the numerator. So in order to bring it up in the numerator, the power, this 3, will change its sign to minus here. So you can see that it has become now 3 to the power minus 3, and of course it is in the numerator again, right? So now once again, when you look here, you can already see here, our base here is 3, right? And then p is minus 3, and then q is 7, okay? So in this type of question, we simply just multiply the power. So you can see here, see, p into q, multiply the power. So minus 3 into 7, minus 3 into 7, we're going to get minus 27. All right, Roman number 3 again. So now this time it is division, right? You can already see here, division is there. And when you look at the base, 11 11, right? So you can see here a, and if it is division, what do? We just subtract the powers, okay? P and Q. So I've written a question here. So once again, the base is same, but the powers are different, P and Q, right? So what do? We subtract them. So you can already see here, 1 by 2 minus 1 by 4. Once again, find the LCM of 2 and 4. 2 1s are 2 then 2 one time, so LCM is going to be 4. Okay, what is my first numerator? 1, so write it down. 2, how many times are 2? 2 2s are 4. Next numerator is minus 1, so I've written here 4. How many times are 4? 4 ones are 4. Once we're done with that, what do we get? 1 into 2 is 2, then 1 ones are 1, right? So you can notice here 2 minus 1 is 1, so our final answer will be 11 1 by 4. Let's do one more. 7 to the power 1 by 2 multiplied by 8 to the power 1 by 2. So you can see here now the base are different. One is 7, the other is 8, but the powers are same, right? The base are different, but the powers are same. So what do? We just multiply the bases here, okay? So what are two bases? 7 and 8. 7 8 is 56, and then the power remains the same, okay? 1 by